Tune in to this week's episode of the DevOps Lab. We have HashiCorp and Rob Barnes back again to talk about workload authentication with HashiCorp Vault into Azure. Welcome to this week's episode of the DevOps Lab. We're back again talking about some really cool features with HashiCorp, and we have Rob Barnes joining us again. So welcome, Rob.
Thank you very much.
Great to have you back. I'm great. Really good to have you back on the show. So tell us what we're going to be talking about today.
Absolutely. So we're going to be talking about how we can use our cloud identities to authenticate with HashiCorp Vault without the need to put any passwords or any other kind of secret information within our source code. So yeah, it's a really interesting topic. It's something that is a big challenge for the security industry, and developers are struggling with this every single day. So I'm going to just show a simple workflow just using some Azure native features and how we take advantage of that with HashiCorp Vault. So let's just have a quick walkthrough and have a look at the problem itself, right?
Cool.
So here we have like a typical kind of layout of how an application may try and talk to a database, right? And the problem is all of the applications here need some sort of database credentials to authenticate and speak to that database. So, you know, to try and get around that, we move to a secrets management kind of way of doing things, which is where HashiCorp Vault comes in, right? So instead of talking directly to the database with credentials, instead, what our applications are going to do is they're going to contact Vault and they're going to ask for credentials for these databases, right? And then once they've got those details, they can go and make their database calls and do whatever it is that the application needs to do. But the problem with that is, you know, we've gone from having database credentials in our application code to now having Vault credentials in our application code, right? So we've centralized our secrets management, but we haven't actually gotten rid of the problem, right? And this is what we call secret zero, right? So secret zero is the secret that unlocks all the other secrets. So if you, as an application, can authenticate to HashiCorp Vault, then you will have access to any secrets that you need to perform your function that you are authorized to access, right? So that's kind of like the main issue that we have here. For humans, it works a little bit different. We have things like OIDC, which allow us to take our identity providers and authenticate with that using a unique piece of information that obviously we can store in our memory. And, you know, we have multi-factor systems to enable us to kind of reset these unique pieces of information should we forget it. So things like a password. But the equivalent for that with an application is to actually hard code a password into the application code. And that's something that we do not want to do. So how are we going to solve this secret zero introduction problem, right? So if we look at Azure, Azure has a really neat feature that a lot of people I speak to haven't actually heard of it before, which is odd because it's very cool. And it's called managed identities. And essentially it allows you to assign an identity to a workload, right? So, you know, if it's a VM, whether it's a serverless application or a Kubernetes pod, whatever it is, you can assign an Azure identity to this workload, right? So that looks something a bit like this, right? So we have all of these VMs which are trying to connect to the database. Now they're trying to connect to HashiCorp Vault, and essentially they're going to use this Azure identity to basically authenticate and say who we are, right? But how can we actually add this to our workloads? I'll show you a quick VM example. So if you've already deployed a VM in the portal, you just need to navigate over to the identity tab on the portal and toggle on the identity. In this case, we have system assigned identity. We have another type as well, which is user assigned. And the main difference between the two is system assigned is tied to the lifecycle of this piece of infrastructure. And generally speaking, the identity cannot be shared with any other workload. Whereas user assigned is an identity that you are provisioning yourself, and you can assign it to one or many different pieces of infrastructure. And when that infrastructure dies, the identity will not die with it, right? So if you needed to, revoke this identity, you would have to manually go in and do that. It's not going to be tied to the lifecycle of any infrastructure. So that's
Yeah,
how you
and
can
then
do it on the portal.
if you have a user leave, you then have to go and manually remove it and remember where you put that user in as well.
Exactly. Or if you decommission an application or something like that, it's there are use cases where a user assigned is a good fit. But generally, I think for what we've laid out in our example, having system assigned is just a lot easier. There's less room for error, which is probably a good way of looking at it, right? So that's how we do it in the portal. But not many people these days are actually deploying production infrastructure using the Azure portal. In fact, they're probably using Terraform, right? So here we just have an example here of just an Azure VM that we're deploying here. And the key thing here is this identity block. So all you would do just to add a system assigned identity is just add this small block to your resource, and that will deploy the identity with the VM in this case, right? So that takes care of the Azure side of things, right? So we have our workloads, we have the identity assigned to it, right? So now we need to start thinking about HashiCorp Vault. So in terms of Vault, I think we may have spoken on this with one of the previous episodes, but we're looking at the auth method, which is the auth method is the thing that allows people or applications to actually authenticate to Vault. Specifically in this case, what we're looking for is the Azure auth method, right? And the way the Azure auth method is going to work is it's going to take this identity and a few pieces of metadata, and it's going to, go to Azure, say, is this actually valid information? And if Azure confirms it's valid, then it will return a Vault token, right? So let's take a look at that workflow in a bit more detail.
Cool.
So as I said, the first thing we have is our VMs, and we have a managed identity attached to that VM, right? So the first thing we want to do is we want to make a API call to the token endpoint, which is it's an endpoint within the VM that is only accessible from that VM. So I can, remotely make that API call and try and get this, right? And essentially what that's going to do is it's going to give us a token for that identity attached to the VM, right? And that's one of the first things that we're going to need. Secondly, we're going to need some metadata about the VM. So it could be things like the subscription ID, it could be things like the VM name or the resource group that the piece of infrastructure is a part of. And how we can do that is we make another API call, and this time it's going to the Instance Metadata Service, right? So that's like another endpoint where you can call it and it gives you all sorts of metadata about this piece of infrastructure. Again, only accessible from this VM, right? If you try and run it from a different VM, you will get the metadata for that VM rather than this one here. Right? So those are the two Azure calls that you're making. Now, we have this information. We want to present this to Vault. So it's a token and the metadata. And the third thing we need is a role. So we spoke a little bit about the Azure auth method. We talked a bit about how it's going to exchange these pieces of information for a Vault token. But it doesn't explain how Vault is going to take care of the authorization. So exactly once you've got this token, what Vault policies should it assign to the token? And that's going to be the Vault role, right? So essentially, we're going to say, this is our token, this is the metadata, and this is the role that we want to authenticate with, right? And then when Vault has that information, it can then go to Azure. It can verify that it is, in fact, a valid token. It can verify the metadata is valid as well. And once it's satisfied that it is valid, then Vault then returns a token with all the policies that are attached to that Vault role. So that's the simple end-to-end workflow of what's going on under the hood. Let's go and take a look at a practical live demo and just actually dive into some code and have a look at how this works in practice.
Absolutely, because I think a lot of us look at identity and either we don't want to touch it or it scares us and it is really complicated. But I think Vault's done a really good job of simplifying this, making the calls to your resources in Azure. So yeah, Rob, show us how we can kind of make this a lot simpler.
Absolutely. So the first thing we're going to want to do is we are going to want to configure Vault to be able to accept authentication requests from our Azure applications, right? So I mentioned in that workflow that Vault is going to have to contact Azure and say, hey, are these details valid? Is this a valid token? Is the metadata in fact correct? So in order for Vault to do that, it's going to need some sort of access to Azure to do that, right? And how we do that is we provision an app registration in Azure AD, right? So here we just got some Terraform code here, and this is actually a module that I wrote. It's free and open source for anyone to use there, and it will deploy an app registration in Azure for you with all the permissions that are required literally to integrate your HashiCorp Vault with Azure. So if you're ever sort of trying to build a solution on Azure and you're not sure exactly what the app registration should look like, it's just easy just to use this resource. It's something that I maintain, and I'm probably even going to donate it to our team so there's more people maintaining it as well. So we have the app registration there. Right. The next thing we're going to want to do is actually configure the Azure auth method, right? Mm-hmm. So again, we have another module. I like to pack these things into modules so that we don't have really big files of Terraform code. We can just package it
and they're easy to modify.
Exactly. Infrastructure as code can also be for things like Vault configuration, which is a key thing that I want people to take away from this. So yeah, essentially we just have this module here. It's got some details about Azure, so the client ID and secret ID of the app that we've just deployed, the app registration, and also the tenant ID and the application URL. So we get all of this information from the previous step, and we just use an interpolation to pass it in, right? So we have our app configured, we have our auth method configured, but we also need to create a role in order for our applications to authenticate with, right? So we'll just go ahead here and create a Vault role. Now this one is not a module. You'd be surprised to hear that I've written. This is just the resource. Not everything is a good candidate for being a module. This is just one resource, so it's probably best just to call it directly. So essentially, we are mounting this role to the Azure auth method that we've created in the previous step. We're creating a role called Azure Developers, and we're giving it a TTL of 60 seconds, which is probably just okay for this demo, but in practice, you probably have something a bit more sensible. We're also saying that it cannot go above 2 minutes in terms of its time to live. And the policies that we're assigning to it is just at the moment, just the default policy. So if you had any other policies that you wanted to assign to it, you would just list it here in the code. And yeah, that's pretty much it. So with that, you can go ahead and deploy that. I've already done that because I want the demo gods to be on my side.
To be kind, absolutely.
Exactly. So we have all the building blocks in place, right? We have everything in Azure. We have everything configured in Vault. So what does that look like in terms of application, right? So let's take a quick look here, right? So essentially what we want to do is we need to set a few environment variables in order to make this work, right? So we want to tell our CLI what the Vault address is, and we want to tell it what the namespace is. Now, the reason why we're doing namespace is we're actually using Vault, a managed Vault, which is on HCP, which is HashiCorp Cloud Platform. It means I don't have to manage all the infrastructure for that. HashiCorp will run it for me, and all I have to do is just take the API that I'm presented with and interact with that. So that's fantastic. So we're just gonna set these environment variables, and we're just in a VM that we've deployed with this identity here, right? So I'm just going to show you a curl example really quickly, right? So if we just examine this code here, we're just using the Vault CLI, and we are authenticating using this Azure Developers role, which we saw earlier on. And the pieces of information we need for this authentication is the JWT, which is the token for the identity. And we need the subscription ID in Azure. We also need the resource group name and the VM name, right? So it's this combination of information that is going to allow us to authenticate with Vault. So how we go about doing that is we're making an API call here to our token service. It's a very long URL. I can post links to the documentation if you want to know these URLs for your own use. And then the second endpoint that we're calling is the Instance Metadata Service, right? Because of the way that we're doing it here, we're literally making the API calls and using the GQ package just to get that specific piece of information we need from the reply and put it inside a variable, right? So we are making that call multiple times here, but in practice, if it were in an application, you probably need to make it once, and then you can just use the information as required, right? So if we just run this, we should get a Vault token. Right? Should. And we do, right? Which is fantastic, right? So if we just examine the feedback we have here, we have the Vault token, which is what we use to log in. We also have the policies which are assigned to the role. So if you remember, we had default as the only policy that was attached to that role there. And you can see some metadata for the VM that we're actually running. So you can see that this belongs to a resource group called Secret Zero Demo. You can see that the role that we have is Azure Developers, and you can see the subscription ID is there, and also the VM name, right? Mm-hmm. So that's really simple. From a VM, you can just make these API calls. But the biggest thing here is you're probably going to be running an application from the VM, right? So how does that look in application code, right? So I have an example of that, which is written in Go. Go is probably what we use the most here at HashiCorp, so it's what I'm most familiar with. So I'll just show a quick example of that. And the first thing I want to examine here is the data structures. So I have a file called models.go. So if you're using any other programming language out there and you're familiar with object-oriented programming, the concept of a class is something you're probably used to. In Go, we tend to use something called structs. So we have a series of structs which represent the format of the data we're going to receive as responses for these API calls. So the first one we have here is when we make the call to the token service. These are the pieces of information that we get back, right? Mm-hmm. And then when we make the second call to the Instance Metadata Service, the format of the JSON is a bit more kind of nested, right? So we have a few different structs which are related to each other. So we have things like the compute object, which has its own things inside it, like the subscription ID, the name, and the resource group. So that takes care of the Instance Metadata Service data structures. And then we have the Vault side of things. So when you make the API call to Vault to authenticate, you're going to get a response, and that response is going to give you your Vault token. And this is what the data structure looks like. Again, nested. So we have a couple of structs which are related to each other, right? We'll just quickly look at some of the API calls. We're not going to examine the files in too much detail because whatever language you're using, it's the concept is you're doing this all using an API, right? You can make a call to the Instance Metadata Service, to the token service, to Vault, and you can do that using whatever language or library that you want to use, right? So the point is we just want to show the pattern, which is why we'll look at the identity service, right? So again, just like we showed in the curl example, we're making a call to this endpoint here, which is exactly the same as in the curl example. And we're just using the request library just to, pass all the information we need to make that API call. There's nothing really special in this. It's the same as just making a curl call, right? And then the other call is the metadata call. So it's the same thing. We're making it to the endpoint there. Now, the difference here is we had to make the call multiple times when we were doing the curl example because we were trying to place different pieces of information in a variable. But in Go, we can make it once, we can get the entire response, and we can unmarshal it into those structs, so that models.go file, and we can just pick what we need for each piece of information, right? So the last thing I'll show you is how we actually authenticate to Vault, right? Now, what I want to draw your attention to is the way that I've written this application is we need to tell the application where Vault is. So I've written it in a way that picks this up from an environment variable. So it essentially looks for an environment variable called Vault_ADDR, which is actually Vault standard variables. And yeah, if that doesn't exist, then it will throw an error, right? The same for the role. We need to authenticate with a role. So we'll set that as an environment variable, which is Vault_role. And lastly, it's the namespace. So we're also looking for the Vault namespace. As mentioned, we're using Vault on HashiCorp Cloud Platform. So we want to make sure that we access the right namespace or we'll get permission denied. And other than that, all we're doing is we're constructing all the different pieces of the payload from the other API calls that we made. And we're making our final API call to Vault. Right? So if I just clear my terminal, and we will just test this out. So I've already compiled this application and pushed it. Again, I didn't want to tempt the demo gods. So we should just be able to run it and get a Vault token back, right? And we do. So we get this Vault token here. So I'm kind of clapping for myself in my head.
It worked.
And it worked indeed. We're going to log in with this just so we can view some information. So here we're logged in, and you can see some of those same pieces of information there. But the other thing I want to do is a quick a Vault token lookup. And the reason why I want to show that is because there's a few things I want you to see. So we can see the path that we use to authenticate is the auth method, the Azure auth method, shall we say.
Yep.
And everything is API, in the API based workflow is path driven. So this is the path that we're making the API call against. The namespace in Vault is the admin namespace. It's default if you're on HCP. And it just has some of the similar metadata that we had in the previous commands, which you can see here, like the resource group name, the role, and the subscription ID. You can see all of this under the meta map. So it's just a map here of all these different pieces of information, right? So this token can't really do much because I haven't assigned it any policies to go and read any secrets or anything like that. But this is how you would do it, right? So in terms of what your workflow looks like as a developer, maybe you wouldn't build this into your application to run every time a function needs to be performed, but maybe what you would have is something like this, which will get the token with a longer TTL and store it somewhere that your application can easily access. So maybe in Key Vault or I don't know, depending on how your application architecture is set up. And then your application just knows that it can always get a Vault token from this location, and this is what I need to perform my function. So yeah, that's pretty much it. We've been able to kind of show some code without any passwords in it. We've been able to securely introduce secret zero. And that is, one of the best workflows in the current climate that we have to be able to centralize your secrets management without risking exposing credentials to your secrets management.
Absolutely. And then we can use that API metadata to access our applications and do things with it as we're trying to build our apps out. So Rob, thank you so much for breaking down HashiCorp's Vault with Azure. Really appreciate you coming on the show today. And for everyone watching, we will put the links in the show notes that Rob has referenced so you can replicate what he's doing and start writing some cool modules. So thanks everyone for joining today.
Thank you so much.